And welcome to section 7.4, the other trig functions. So before today, we've talked about sine and cosine, and today we'll add a secant, cosecant, tangent, and cotangent, and we'll especially talk about these functions at pi thirds, pi fourths, and pi sixths. And remember that those are just written in radians, but they correlate with an angle that we could also write in degrees. Well, these angles are at 60 degrees, which correlates with that pi thirds, 45 degrees, which is pi fourths, and then 30 degrees, which is pi sixths. So just for a moment, since we've been talking about trig for a while, I just want you guys to think about, why is this subject so important and why do we learn it? Well, we'll get to more information about trig and its connection to functions and that world. But if we think about trigonometry, it's a lot like in the geometry, in the sense that it helps us with things that are all around us. If we want to be sure that we have the certain measurement correct, then we need to use the math to make sure that all the sides are mathematically sound, right? So this is the kind of stuff that we don't think about very often. But if it didn't exist, then there wouldn't be certain truths around us that hold. And right angles wouldn't necessarily be right angles. We would just wouldn't have a definite definition of them. So I just, something to ponder, and something that you could also definitely look up and see if there's something hidden that we don't know that uses trig. Okay, so let's go right into these other trig functions. So the first one we'll talk about is called tangent. And tangent is closely related to sine and cosine because we can find tangent by just dividing sine over cosine. Or if we're using our right triangle on the coordinate plane, we could assign x and y here. And so tangent would be y over x, or opposite over hypotenuse. And so we abbreviate this as tan, T-A-N, and the angle, or sorry, the tangent. If we're looking at the coordinate, sometimes it's sitting outside of that coordinate if we're looking at maybe like a unit circle. So remember that our coordinates can also be written as cosine, in this case t, and then sine of t. Moving on to cotangent. Cotangent is the reciprocal of tangent. So for each of these main functions, sine, cosine, and tangent, there are reciprocals that relate to them. So cotangent, abbreviated COT, is the ratio of, and I want you guys to change this, it's not y over the x, it's going to be x over the y value. So you guys can see that here. Or we could also write it as cosine over sine, since tangent was sine over cosine, and this is supposed to just be the reciprocal. Let's also introduce secant. So secant is the ratio of, we're going to change this, 1 to x. So we'll have secant is equal to 1 over x, or 1 over cosine of t. Moving on to cosecant. Cosecant will be the reciprocal of sine, and this one will be the ratio of 1 to y, and we can also just write that as 1 over sine of t. And since we're dealing with a denominator here on all of these, we want to be sure that our denominator is not equal to 0, otherwise that is not defined. So let's start with example 1, finding the trig functions from a point on the unit circle. So we're given this point at negative square root of 3 over 2, 1/2. So first we need to gather everything that we know. What we know is that that coordinate represents sine and cosine. So I actually already have the answers for the first two. We're going to go through here and find all 6 trig functions from just that point. So since sine of t would be the second number in that ordered pair, that will be 1/2. And then cosine of t would be the first number in the ordered pair, which is negative square root of 3/2. Now, if you're wondering, why is that negative? Why is that positive? Well, if we think about the way coordinate planes work, when we use the x-axis, if we go to the right, then that's positive. If we go to the left, that's negative. On the y-axis, if we go up, that's positive. If we go down, that's negative. So we would just graph that like a regular coordinate. Our x value is negative, our y value is positive. We can also remember which values are positive and negative in certain quadrants with this little mnemonic phrase. All students take calculus or a smart trig class. And those letters represent what functions are positive in that quadrant. So the A stands for all. All of those functions are positive in quadrant 1. S stands for sine, and it's reciprocal. T, tangent and cotangent. And then quadrant 4 will be cosine, and it's reciprocal. So now that we have those, let's go ahead and find the others. I think the next one that might be kind of easy to find would be tangent. As we know, tangent is going to be sine over cosine. And we know what sine is, which is 1/2. We know what cosine is, negative square root of 3/2. So now what I need to do is just divide those two. I have a complex fraction here, so I'm going to rewrite it so that my fractions are lined up. And then as I know, when I divide fractions, I'm actually multiplying by their reciprocal. So I end up with this new problem, 1/2 times negative 2 over the square root of 3. So my 2's will simplify, and what I'm left with is negative 1 over square root of 3. Now we'll just rationalize that by multiplying square root of 3 over square root of 3, which will leave us with negative square root of 3 over 3. And so that's our answer for tangent. We ran out of room, so I'm going to keep going. So far, we've taken care of sine, cosine, tangent, and those last 3 will be the reciprocals of what we already have. So if I want to find the reciprocal of, let's say, sine, that's going to be cosecant, which we said was 1 over the y value, or 1 over sine of the angle. So we know that sine was originally 1/2. So now we just need to divide 1 and 1/2. So we'll have 1 times 2, which comes out to 2. So cosecant of this angle will be 2. Now let's find secant. Secant is the reciprocal of cosine, or 1 over x. Okay, so I'm going to divide 1 over cosine, which was originally negative square root of 3/2. If you're wondering, can I just take my answer for cosine and just flip it around? You can, actually. So this answer that I get from doing 1 divided by negative square root of 3/2, I'll go ahead and work it out, and then I'll show you guys that, yes, you can make it just flip. And so we'll get 1 times 2 over square root of 3, which will come out to be negative. I forgot there was a negative on here, guys. Sorry about that. Negative 2 square root of 3/3 after I rationalize. So if I would have just taken what cosine was, which was negative square root of 3/2, and then just written the reciprocal, which would have been 2 over square root of 3, or negative 2 over square root of 3, I could have just gotten the same exact answer. I rationalize, and we end up with negative 2 square root of 3 over 3. So you notice those are the same. So you can take that shortcut if you need to. I'm going to finish cotangent on one sheet of paper here. So cotangent of that angle. Well, let's go back and find out what we said tangent was. So a second ago, when we found tangent, we said it was negative square root of 3 over 3. So cotangent is going to be the reciprocal of negative square root of 3 over 3. So we can just write that as 3 over negative square root of 3. Rationalize my denominator, and we get negative 3 square root of 3 over 3. Those 3's will cancel out by division, and we end up with negative square root of 3, and that's cotangent. So we just went through all 6 trig functions. Now I want you guys to try one on your own. So this one says that the point square root of 2 over 2 is equal to negative square root of 2 over 2 on the unit circle. And what I would like for you guys to find is sine, cosine, tangent, secant, cosecant, and cotangent. Now, that is a lot, considering the problem that we have here, right? But it's actually not too much because these are the same. So we know sine is going to be the second number here, which is negative square root of 2 over 2. We know that cosine is going to be the first number in our ordered pair, which is square root of 2 over 2. We know tangent will be negative square root of 2 over 2 divided by square root of 2 over 2. And so when we rewrite that as a multiplication problem, because we reciprocate, and we end up with just negative 1. Okay, so cotangent would be the reciprocal of negative 1, which is negative 1. And then secant would be the reciprocal of cosine, which is 2 over square root of 2. So I can rationalize that. And the reason, or the way I got that so fast was I just looked at what cosine was and I flipped the fraction. So then now I'm just rationalizing. Multiplying by square root of 2 gives me 2 square root of 2 in the numerator, and I end up with just 2 in the denominator. And then finally, cosecant is going to be the reciprocal of sine, so now it'll be negative 2 over square root of 2, which is exactly what I just did, but now that one is negative, so it'll be negative square root of 2. Finally, we have an example here where we are given t, which is the angle, and we want to find sine, cosine, tangent, secant, cosecant, and cotangent. So again, you're always welcome to stop and work these problems out on your own before I work them out, or you're welcome to follow along. So first of all, we need to remember, what is pi over 6? So pi over 6 is actually 30 degrees. 30 degrees is where our cosine is square root of 3 over 2, and sine is 1/2. So again, I already know these just from knowing the coordinates on the unit circle. So 1/2 for sine and square root of 3 over 2 for cosine. Now I'm going to go ahead and find just the reciprocal of sine, which is cosecant. So the reciprocal of 1/2 is 2. Then the reciprocal of cosine is secant, and that reciprocal would be 2 over square root of 3. Rationalize the denominator by multiplying square root of 3 over 3, and we end up with 2 square root of 3 over 3. Now, tangent would be sine, which is 1/2, divided by cosine, which is square root of 3 over 2. So I can rewrite that as 1/2 times 2 over square root of 3, and we have 1 over square root of 3. Rationalize the denominator again, and we end up with square root of 3 over 3. Finally, the reciprocal of tangent is cotangent, and the reciprocal of square root of 3 over 3 would be 3 over square root of 3. Rationalize again, and we have 3 square root of 3 over 3. Those 3's will divide out, and we have square root of 3. So there are all 6 of our functions, and we found that quickly. As soon as we knew sine and cosine, we can just divide to find tangent, and then we reciprocate to find the other 3. So here is a list of all of those functions and what the measurement is there. So like cosine at 0 is 1. Cosine at pi 6 or 30 degrees is square root of 3 over 2. So this is a good place where you might want to write these down or take a picture wherever you're keeping your notes. This is something to definitely bookmark. Or you may just know these by heart by using your knowledge of the unit circle. And then this is just to reiterate how we were able to know which functions were positive in which quadrants. So in quadrant 1, all functions will be positive. In quadrant 2, sine and its reciprocal cosecant will be positive. In quadrant 3, tangent and its reciprocal cotangent are positive. And then in quadrant 4, we have cosecant and secant are reciprocals of each other. And those are positive functions. So this is all for part 1. There will be a follow-up video of part 2 and the rest of these notes. Thank you guys, and I'll see you next time.